Welcome to Modernize Your Data Warehouse session. I'm Harshita Patel, a specialist data warehousing solution architect at Amazon Web Services. In today's session, we'll cover why customers are choosing a data lakehouse approach to analytics. We'll cover modern data analytics in Amazon Redshift, followed by what's new with Amazon Redshift and how you can get started. Before I start, I would love to tell you a story about a customer I work with, Nielsen. Nielsen produces data and analysis that enables decisions. The TV measurement application measures everyone everywhere. TV measurement has dramatically evolved due to the evolution of how the content is being consumed and the massive increase in the total volume of content being produced. This required Nielsen to re-evaluate their architecture. Nielsen was using on-premise data warehouse based on Netezza with a monolithic architecture, which had limited scale. Nielsen used this opportunity to re-architect the solution and use the right technology for their use case. Nielsen started with a solid foundation of a data lake platform with petabyte scale data. This served as a single source of truth. Moving up the stack, Amazon Redshift for their daily analysis on the data to meet the tight SLA. Amazon EMR for transient batch processing. This purpose-built solution allowed them to orchestrate end-to-end. This allowed them the scale and the elasticity needed to handle the massive volume in the content and the complexity that is required for data processing to generate the insights. This solution was also provided them the flexibility to further continue to optimize on cost by leveraging spot instances. I work with customers, and what we hear is customers want to generate or derive more insight based on your data so that they can transform their customer experiences and differentiate the business. But the common challenges they struggle with: how to capture, store, and analyze all the data that they are getting from their modern and digital businesses. The volume of the data is scaling exponentially because of the new data sources. The data freshness requirements are changing, with a strong requirement of a security layer that they can allow access to all applications and people within the department. The solution, which is not compromising on performance, as well as it's cost-effective. This is where Amazon Redshift has enabled customers to handle data analytics at scale. To break the data silos, customers are moving towards a data lake architecture. With a data lake, it allows them to store structured data along with unstructured, as well as data coming in near real time from clickstream IoT devices. With Amazon Redshift, you leverage the data warehousing capability, but it also enables you to access and join the data that is in your data lake. This architecture of where you can extend your data warehouse capability to the data lake is what we call a lakehouse architecture. AWS provides breadth and depth of analytical services. These services are purpose-built, and they are fully managed, which takes away the undifferentiated heavy lifting of managing and maintaining the infrastructure. While we talk to customers on their migration journey, the first thing they bring up is, I want to break free from my perpetual licensing and having to manage and maintain the application on-premise, but they have a need to continue to use similar technology stack. To list few of the examples, customers who have relational databases on-premise, Oracle, or SQL Server, they can consider to move to Amazon RDS or Modernize using Amazon Aurora. Customers who are managing a Hadoop stack which is on-premise, they can consider to move to Amazon EMR. And for customers who are leveraging on-premise data warehouses, legacy data warehouses, when they want to modernize on their journey, they can migrate their workload to Amazon Redshift. I'd like to share the key benefits of Amazon Redshift. One is the pure integration and clean integration with Data Lake. It also provides native integration with services such as lake formation, which you can use for access control of your data lake, but also leverage the column-level security that Lake Formation provides. Integration with services such as CloudWatch for monitoring and alerting. Performance improvement in Redshift has dramatically increased. The out-of-box performance over the last year provides 3x to 4x improvement. And we try to drive down the value or the cost with better price performance. It also allows you to scale as your data volume increases or your end user concurrency increases. You can scale an Amazon Redshift cluster from 160 gigabyte all the way to 8.2 petabyte compressed storage. And with the integration with the data lake, you can scale to exabyte. This scaling up and scaling down happens in a matter of minutes. And core to Redshift is security. Redshift provides security at rest. You can entirely encrypt a Redshift cluster, as well as you can encrypt your access when you're running queries in transit. It also has compliance certifications with HIPAA, FedRAMP, PCI, SOC 1, SOC 2, SOC 3 to meet your security needs. And it's fully managed, which takes away the undifferentiated heavy lifting from you. Amazon Redshift is used over tens of thousands of customers worldwide, with different verticals, which provides us the insight into what the needs of the customers are to help us innovate this service. As a solution architect, I love to talk about architecture and concepts of Amazon Redshift. You as an end user, whether you're using a SQL client or any of the BI products, you connect to the leader node using a JDBC or ODBC driver. Behind the leader node, you can have 2 or more compute nodes. When you execute a query, the leader node parses the query, compiles that query, and sends that compiled code to the compute node. So when the query is executing, each and every compute node is working in parallel. This is what we call massively parallel processing, shared nothing architecture. The compute nodes also integrate with Amazon S3, which serves as your data lake, from which you can load and unload the data, as well as Redshift being a fully managed service, it takes incremental snapshots and incremental snapshots on Amazon S3. Amazon Redshift Spectrum is the layer that sits between the compute node and Amazon S3. This is the elastic layer, so when you execute a query to access the data which is sitting on S3 in any of the open formats such as ORC, JSON, CSV, Avro, or Parquet, Amazon Redshift Spectrum pushes down that computation and allows you to query the data which is sitting on S3. With Spectrum, you also have the ability to join the data, which is in your data warehouse on Redshift, as well as to the data on Data Lake. I've seen customers use Amazon Redshift Spectrum for different patterns. One is to push down the cold data onto S3 and have hot data on Redshift. The other pattern is to do ELT to ingest the data into Redshift, as well as we have customers having near real-time data which is coming in their data lake, and they leverage Redshift Spectrum to query the data as and when it's arriving. This architecture has evolved. You still have the leader node, you still have the compute node, but now you have Redshift Managed Storage. With Redshift Managed Storage, it allows you the separation between compute and storage. The managed storage is a combination of local SSD cache and S3. And Redshift automatically handles the movement between local SSD cache and S3 based on your access pattern. This allows customers to scale their Amazon Redshift cluster to 8.2 petabyte scale. Redshift is columnar in nature, so when it stores data on disk, it is column by column. And this columnar architecture lends itself very well for analytical queries. When you are writing an analytical query, joining 2 tables, which could have hundreds of columns, you're selecting subset of the columns and performing aggregation on millions of records. With the columnar architecture, it reduces the I/O and hence improves the query performance. I hear from customers a commonly asked question: how can Redshift handle concurrent thousands of users? So Redshift has this feature, concurrency scaling. You can choose to turn on this feature, and when you have turned on this feature, Amazon Redshift automatically detects queuing is occurring. And when queuing is occurring, it will spin up transient clusters and start routing the queued up queries on the transient cluster. And when the spike goes down, it relinquishes this transient cluster. This is what Redshift automatically handles it for you. Let me build up the slides here. With every 24-hour use of your main cluster, you get 1 hour of concurrency scaling capacity for free. You can accrue total of 30 hours during a month. You can leverage concurrency scaling Now we also have cost controls for concurrency scaling. Elastic resize enables you to scale up a cluster or scale down a cluster in a matter of minutes. Say, for instance, you have a weekend-heavy workload or a quarterly refresh or very heavy reporting workload on Monday morning. Customers elastically scale up the cluster using elastic resize in a matter of minutes so that it enables them to run that workload in half the time or with linear performance. And when the workload is completed, they elastically resize down the cluster. So we looked at how Amazon Redshift allows you to integrate with your data lake to break the data silos. When your data increases, how you can leverage the scale of Amazon Redshift, not only just the managed storage, but also S3 from a storage perspective. Concurrency scaling allows you to handle your spiky workload for concurrent users. And with elastic resize, you can scale up the cluster or you can scale down the cluster in a matter of minutes. I really love working with AWS and Amazon Redshift. There is always something new to learn and share with customers. If we look at the course of last year, there are more than 200 features and capability that the Redshift service team has added. This roadmap is based on our end users. We have tens of thousands of customers across different verticals globally using Amazon Redshift. Let me highlight a few of the key areas in this innovation. Performance and scalability is at the heart and the core of the service. But what I would like to touch on is the fully managed aspect and ease of use. Redshift provides you to use automatic WLM or workload management, where Redshift automatically handles the concurrency as well as it alleviates the need to carve out workload management. There are also automatic worker threads which are running in the background to auto-analyze, auto-vacuum delete, auto-table sort, as well as there are recommendations which are available to you on your console through Redshift Advisor on optimal distribution, as well as sort keys. So Redshift is significantly, by introducing this automated feature, making it easy for you to use Amazon Redshift. Let's touch on RE3. RE3 instances were announced during last reInvent in 2019. And since its announcement, we have seen a number of customers upgrading to RE3 and benefiting from the Nitro system, the high bandwidth, as well as the separation of compute and storage. Customers can now size their cluster to their compute needs and only pay for the storage that they are consuming. To take this step further, Aqua, which is the advanced query accelerator, provides distributed caching. The compute is now with Aqua close to the managed storage, which allows to significantly improve the performance of operations such as encryption, compression, filtering, aggregation. For customers who are using RE3, Aqua will come for a ride. You can sign up for the preview. Materialize View is GA, which again takes a step further to improve the performance. Say you have a simple query or a complex query, you can convert that into materialized view, which physicalizes the data. And when the end users are accessing, they are accessing the content which is physicalized. So it improves significantly the performance of those repeated queries. When the data in the underlying table is changing, you can incrementally refresh the materialized view, which simplifies and reduces your ETL pipeline. Amazon Redshift federated query feature breaks the data silo. With this feature, now analytical community or analytical users have the ability to run analytical queries directly in their operational data stores, sitting on Postgres, whether it is Amazon Aurora or Amazon RDS. So with the integration of federated query, the ability to integrate to your data lake, when an end user writes a query, it provides them a unified view. When they write a query, Redshift Optimizer has machine learning, and it's significantly faster. It pushes down that computation to respective data sources to reduce the data movement. So we reviewed how Amazon Redshift can help you modernize your data warehouse. Now let's see how you can get started. AWS provides schema conversion tool to help you jumpstart with your migration, allowing you to convert your source schema as well as your application code to Amazon Redshift equivalent. SCT also has data extractor, which I will review in a minute. You can also leverage database migration service to migrate your data from your source system into Amazon Redshift. When I work with customers, I highly recommend to use SCT, which allows you schema conversion, but it also provides you an assessment report, and it provides you an assessment report and executive summary, which gives you insight into the level of effort involved with migration. It will highlight what objects it cannot convert. Say, for example, blobs, it cannot convert. It would give you a recommendation. So this assessment report is a nice start to give you insight on the effort involved with migration. If you're dealing with data on your data sources, which is more than 15 terabytes, you can consider to use SCT data extractors. Database migration also helps you to migrate the data homogeneous or to heterogeneous. Say, for example, if you have your transactional source system, say Oracle or SQL Server on-prem, and you want to migrate that to Amazon Redshift, you can leverage database migration service. It also allows you to capture change data from the transactional logs. So you can keep your source in sync with Amazon Redshift. I've greatly seen customers do that during their migration process or when they are performing POC. AWS has a broad ecosystem of partners which can help you jumpstart in your migration. They are certified, highly skilled, and help you with successful modernization and migration. You can choose from our consulting partners, or you can also choose from our technology partners, to build your ETL pipeline. Here are a few of the links for your learnings. I would highly recommend you to review our customer stories. And would love to be part of your modernization and migration journey, you can request a briefing. If you're curious to learn more about, we have free digital courses offered both on the database as well as on the analytical side. Thank you so much.